G'day folks. Well, I had a bunch of people asking what a microwave inverter is, and well, this is one here, and it's essentially a replacement for an old iron core microwave transformer. You don't get it as a replacement for any microwave, they're built at the factory, but this is what they're putting in microwaves now. It's obviously a lot lighter, a lot more complicated, but it does give you variable frequency control over the magnetron, so it makes cooking a lot easier. You get better power control. I've got a Panasonic inverter microwave, a newer version of what this came out of, and it's lasted the last 5 years just fine, and it's actually really good to cook with, a lot better than the ones with the iron core transformers and regular capacitors. But of course the old ones seem to last a lot longer, but the new ones don't seem to last as long, even though mine's lasting quite a while. It doesn't get used very regularly, like it gets used once or twice a day. Like, it's not flat out in a commercial environment, but it still does the job pretty good. And as you can see, it's got a flyback style transformer with a ferrite core. The thick outer winding is connected to mains DC, rectified mains positive and negative through the power switching transistors in there. So that's the primary side, also connected through these capacitors. The secondary side has 5 volts and the high voltage, which would be about 2 kV. I think that's 5 volts, these two wires here, and 2 kV comes out through these other traces, because there's your magnetron connections right there. Those are the only 2 caps on it, and of course there's the normal diodes, as you'd find in any microwave, but there's no big oil-filled capacitors anymore. That's it, that's the high voltage side, where that board, those slots are. They pretty much isolate most of the board from the high voltage side. It's just that corner there. That's ground, it's got the ground lead on it and everything, and that's the actual inverter main side, live side, DC. There's a bridge rectifier in there, like a 20 amp or 15 amp bridge rectifier. RS20, yeah, 20 amp bridge rectifier. I can't make out the markings on this big IC. It's still a 3-pin chip. It's probably the main power switching transistor, even though the base of this one here, which is a Toshiba J322 Toshiba. So that's another power switching transistor, and the base of that's connected straight to the big thick primary winding from DC negative, I think it is. Yeah, there's a wire bridge going across there, and you run down the side of the board to that inductor. Sorry, DC positive goes through there to the inductor, wire bridge and trace, wire bridge to the base of that transistor, and also to that side of the winding. So you got base and one side of the primary connected to DC positive, and you've also got the other side of the primary going through here to the other big transistor, which I can't identify. And it's, where is it connected through? So there's DC negative on the rectifier, AC are the 2 center pins, so that's 240 volts AC going in from the mains. DC positive is connected to the base collector emitter of the big one in the center. So yeah, very basic power inverter. I'm not sure how to power these up. I think Photonic Induction played around with them and said you need a square wave, like a 5 kilohertz square wave signal in through this connector here or something. I'm really not sure. Maybe someone's got one of these to work just off a basic driver. I think Alex993CC1 has one of these on his bench that he's driving with a ZVS. Just wind your own primary around the core or something, or maybe using the existing primary. Actually, you could use this. It's just a wound fine multi-strand wire. I haven't actually seen the video, it was broken last time I went to look at it, but that's probably a problem on my PC end. I'll go back and watch it immediately after I post this, and post a link in the description if it is what I think it is. But yeah, that's what replaces a microwave transformer. And you got logic control in there. Nothing too special, I'm not sure what that chip is. AN, first 2 digits AN. Come on. AN90P075B. Yeah, it's a little logic controller chip or something. Anyway, not much else to it other than that. This is a good spare inverter for my microwave. It's identical, even though it's a little bit older. I'm not sure whether or not I want to butcher it. Yeah, it can sit on the shelf. I'll let other people have their fun with these things. I don't think there's much to gain from it, but who knows. You might be able to use the ferrites and rewind the bobbin with your own windings, since it's not potted in epoxy. At least as far as I know. Last time I chopped one of these up for scrap, I don't believe any of it was potted in epoxy. It's just wrapped in insulating tape, which is kind of unusual. There's no big barrier between high voltage and low voltage on the inverter. And 250 volt DC is still low voltage, it's not high voltage. Same with your 110 volt wall outlets, that's still classed as low voltage. 12 volts or 3 volts, like the 3 volts that's powering the LEDs in my little rack here, that's classed as extra low voltage. There's a hard drive LED in there for the PC. I did that last night, a little project. I got bored. I thought I'd put that rack on the wall instead of on the shelf. But yeah, that's just one of the fun things you can do with scrap electronics. And this thing, well, spare parts, or I'll find something fun to do with it. I've got plenty of microwaves anyway, so who knows. We might find something fun. Anyway, thanks for watching and stay tuned for more. I just thought I'd give you a little bit of a rundown on them.